So now, getting to this junction, we are going to have to integrate this part all over again. So from here, we are going to make one u and we are going to make the other one du. So let's make this one u and let's make this one dv. So that means our u is equals to x and our v is equals to e raised to power 5x, because 2 over 5 is going to become a constant. 2 over 5 is going to come out right here. So we have e raised to power 5x. So from here, and that is for the v. So from here, we are going to find for du. Our du is equals to, when you differentiate this, it's going to give us 1. We are going to have 1, and our dv here is going to give us, our dv when we integrate it back, is going to give us 1 over 5. This one will give us 1 over 5 times e raised to power 5x. So from here we can differentiate this one all over again, and you remember the formula that says v u dv is equals to uv minus v du. So our u times v, we have our 1 over 5 times x e raised to power 5x minus our integral of v du. That is integral of our v is 1 over 5 times e raised to power 5x, and our du is 1. So that is everything multiplied by 1. That is times 1, which will also be the same thing. So from here we can continue. We have 1 over 5 x raised to power e raised to power 5x minus, when we integrate this one, we are going to integrate this part all over again. When we multiply this, we still have this, but we are going to integrate this one all over again, and we are going to have 1 over 5. This 1 over 5, after integrating, multiplied by the main one, 1 over 5 times e raised to power 5x. Now this is the value that we got for this second part of the equation. Then we can try to put them together. Then when we put them together, we are going to have here 1 all over 5 times x squared e raised to power 5x, then minus, now this 2 over 5, I said we bring it out the earlier time, we have minus 2 over 5. Now in brackets, what we integrated here, we put it there. We have times 1 all over 5 x, 1 all over 5x times e raised to power 5x minus, we have 1 all over 5 times 1 all over 5, that is 1 all over 25, minus 1 all over 25 times e raised to power 5x. So this is how it will be. So when we are getting our final answer, like when we try to simplify everything here, when we try to simplify everything here, we can have 1 all over 5 x squared times e raised to power 5x, 2 over 5 multiplied by this one, that is minus 2 all over 5 times 5, 25, 2 all over 25x times e raised to power 5x minus 2 all over 5 times 25, 125. So that is 2 all over 125 times e raised to power 5x. And this is our answer for the 2B of the. So the question 3A of the Maths 103, the 2016-2017 version states, it says find the equation of the tangent and the normal to the curve y is equals to x cubed minus 2x squared plus 3x minus 1 at the point p is equals to 2 and 5. That is at the point p 2 and 5 in brackets. So what are we going to do here? They ask us to find for the normal of the curve. That is to say, if we have, if to say this curve is something like this, they are asking us to find for the straight line that is normal to the curve. That is what they mean. So for us to find for the equation of the normal to the curve, the equation of a straight line is what we are using. So the equation of a straight line is y is equals to mx plus c. This is the equation of a straight line. But for us to be able to get this equation, we need to get our m, which is our gradient. That is our slope, our gradient. So for us to find our gradient, we have to differentiate this one here. We do it this way. We have if this is y, the y, the x of this, it will give us 3x squared minus, this is 4x plus 3 as the differentiation. So this is the dy dx is also the same thing as gradient. So our dy dx, which is the same thing as m here, is equals to this 3x squared minus 4x plus 3. So from here we need to get an actual value. So they have given us the value of x here, that is at the points p, 2 and 5. This 2 here is for the x-axis and this 5 here is for the y-axis in the graph. So when we have our gradient, that means our gradient here, m is equals to, since we only have x here, we input our values of x, which is 2. So we have 3 open bracket 2 square minus 4 times 2 plus 3. From here we can get our gradient as 3 times 2 square, this is 12, minus 4 times 2, 8 plus 3. So when we add 12 minus 8, we get 4. 4 plus 3, we have 7. That means our gradient is equals to 7. So we have gotten our value for m. So now if we put our m into this equation, we will have something like y is equals to 7x plus c, something like this. We are getting closer to the equation. So now we need to find for this constant here. For us to find for this constant and come back to our equation, we can use these same values that they give us here, which is this x and y. So here we have our y is equals to 5. So we have here 5 is equals to 7 times, our x here is equals to 2. 7 times 2 plus c. From here we can make c the subject of formula. We have 5 minus, when this 7 times 2 come in, become minus 7 times 2 is equals to c. We have 5 minus 7 times 2 is equals to 14 equals to c. That means 5 minus 14 is minus 9. That means minus 9 is equals to c. Therefore our c is equals to minus 9. So since we have gotten our value of c, we can come back and get our equation proper. We will have the final equation, the equation of the line will be equals to y is equals to 7x plus c, but c is equals to minus 9, that is 7x minus 9. So this is our final answer for here. So right here in the 3b of the past question, it says evaluate integral 2 to 1 integral 4 to 2 in brackets x plus 2y dx dy. Now, from the look of this question, it's looking kind of complicated, but once we break it down, it will be much more easier to solve. We are going to solve this, the inside one first, this one here with dx. Then after getting our final answer, we are now going to integrate it again using dy. Let me illustrate it here. We will have it as integral 2 to 1, then we open our bracket. So we are dealing with the one inside the bracket first. Inside the bracket will be this one here, which is integral 4 to 2, open bracket, 4 plus 2y, close bracket, dx. Then we now close the big bracket for this. So then we write our dy outside. So from here it should be a little bit clearer. So from here we are going to be solving the one inside the bracket. Then when we get our final answer, we integrate it again using dy. So solving the one inside the bracket now, we have let me put this outside. We have integral 2 to 1, open our brackets. Then inside the brackets, after integrating this, we will have 4x. If we integrate it with respect to x, we have 4x plus no. So now we start integrating. We put it here, 2 to 1, open our brackets. So when we integrate this one with respect to x, we have x square all over 2 using the law of integration. Then when we integrate this one, it will be plus 2yx. So all this here, I have to put inside another smaller bracket with respect to 4 and 2 here, dy. Now solving this one inside the bracket here now, if we are solving this one inside the bracket here now, we do x equals to, when x is equals to 4 minus when x is equals to 2. That means here we'll be having 4 square over 2 minus 2 square all over 2 plus this one here, which is 2y times 4, 2y times 4 minus 2y times 2, something like this. Then when we simplify it, we have 4 square, we have 16 all over 2 minus 2 square, which is 4 all over 2 plus 2 times 4, we have plus 8y minus 2 minus 4y. Then finally simplifying it, we have 16 minus 4, we have 12 here over 2 . So here we have our 12 all over 2 here minus 12 over 2, if we put this together, plus 8y minus 4y, which is equals to 4y. So then when we get the answer, 2 here 1, 2 here 6. So the final answer of this is equals to 6 plus 4y. That is the final answer. This is the final answer here when we simplify these brackets here. So let's note this down. So now, since we got the simplification of this as 6 plus 4y, we'll have this here, that means 2 of 1 in bracket 6 plus 4y close bracket dy. Do you guys understand? After solving the first one, then we are going to use the answer, then we solve the second one. So how do we solve this? First of all, we do our normal integration again. We have in bracket here, we have integration of 6 is 6y plus integration of 4y is 4y square all over 2 close bracket. Then we put our signs here, which is 2 and 1. So that means we are going to, when y is equals to 1 minus when y is equals to 2 minus when y is equals to 1. Now we can still simplify this. 2 goes here, remains 2. That means we have 6y plus 2y square in brackets of 2 and 1. So now doing it the same way we did the initial one, 6y here, when y is equal to 2, it will be 6 times 2, that is 6y when y is equal to 2, minus when y is equal to 1, that is minus 6 times 1 based on the values here. So plus 2y square, that is 2 times 2 square, 2 times 2 square minus 2 times 1 square. So after simplifying everything, we have 6 times 2, which is 12, minus 6 times 1, which is 6, plus 2 times 2 square, which is 8, minus 2 times 1 square, which is minus 2. So from here we have 12 minus 6 is 6, 8 minus 2 is 6. So the final answer here is equals to 12. So that means this question here, the final answer is equals to 12. So in the question 4a of the past question, it states that find dy dx if x is equals to 2 minus 3t over 1 plus t and y is equals to 3t minus 2 over 1 plus t. So how are we going to do that? We are going to use this formula that states that dy dx is equals to dy dt times dt dx. This is the formula that we're going to use to get our answer. So how do we do this? To find dy dx, first of all, we have to find for dy dt. Then after finding for dy dt, then we find for dt dx, that is 1 over dx dt. That is the inverse of dx dt. So here's how we do it. So finding for our dy dt, our y is equals to this. So in order to differentiate this, we cannot just differentiate this directly. We have to use the quotient rule. We pick this as our u, we pick this one as our v. So that means our u is equals to 3t minus 2, then our v is equals to 1 plus t. So therefore our du dt is equals to, when we differentiate this, we have 3, and our dv dt is equals to, when we differentiate this, we have 1. That is for this y here. Then we use our quotient to, we get u times, we have v times du dt minus u times dv dt all over v square. So we have our v is 1 plus t, we have 1 plus t times du dt, which is 3, minus, what is our u? Our u is 3t minus 2 multiplied by our dv dt, which is 1. Everything divided by v square. That is the formula for quotient rule. So from here, when we expand it, we can have something like 3 times um this is no this also be 1 plus t. So after, when we want to expand this, we can have something like 3 times 1. Here we have 3 plus 3 times t, 3t minus 1. Here multiply everything will give us the same thing. We have here minus 3t again, then minus times minus 2. We have plus 2 all over 1 plus t all square. So from here we have plus t and minus 3t, they can cancel each other. Then we have 3 plus 2, which is equals to, we have our final answer here as 5 all over 1 plus t all square. First of all, now we have gotten our answer for dy dt. We put it somewhere. That means dy dt is equals to 5 all over 1 plus t all square. Then we move on to our x here, finding for dt dx. Now is for us to find for dt dx, we have to find for dx dt, then we change it to the inverse. So finding for dx dt, we identify this one as u, identify this one as v, in order to be able to use the same quotient rule. So u is equals to 2 minus 3t and v is equals to 1 plus t. Then our du dt is equals to minus 3. Our dv dt is equals to 1 here. So using the quotient rule that states that v du minus u dv all over v square is the quotient rule. This is the formula for the quotient rule. So that is the formula that we are going to be using. We have our v here is 1 plus t, close the bracket, times du. What is our du dt? Minus 3 times minus 3 times minus 3. Then minus here, what is our u? Our u is equals to 2 minus 3t times dv dt is equals to 1. Everything divided by v square. Our v is 1 plus t. We have 1 plus t all square. So from here we can simplify it. 3 times minus 3 times 1, we have minus 3 plus minus 3 times t minus 3t. Then minus times 2, we have minus 2. Then minus times minus 3t, we have plus 3t. Because 1 multiplied by everything is still 1. So everything here divided by 1 plus t square. So we have 3 minus 3, then we have plus 3t minus 3t. So minus 3t will cancel plus 3t. The answer will be equals to minus 3 minus 3 minus 6 all over 1 plus t all square. This is our value for dx dt. So since we are having our dx dt is equals to 6 all over 1 minus 6 all over 1 plus t all square, we are going to have our dt dx is going to be the opposite. We are going to turn it upside down. So our dt dx here will be equals to 1 plus t all square all over minus 6. That is the value for dt dx. Then Now we have gotten our differentials. So what we just have to do is use our formula that I wrote that states that dy dx is equals to dy dt times dt dx. So here we have our dy dt here as this, and we have our dt dx as this. We multiply them together. Dy dx is equals to dy dt here, which is 5 all over 1 plus t all square, times dt dx here is 1 plus t all square all over minus 6. So from the view of this, 1 plus t square can cancel 1 plus t square. We have our dy dx as 5 all over minus 6, which is t equals to minus 5 over 6. So this is our dy dx. dy dx is equals to minus 5 all over 6. So the question 4b says that the slope of a curve is 6x plus 2 and it passes through the point 1 and 3. That is, the point x is equals to 1 and y is equals to 3 in a graph. So find the equation of the curve. Now earlier we were told to find for the slope the tangent to the curve, which is like the slope. I'll use the equation to get the slope. So when they're talking about slope, slope is the same thing as gradient, and gradient is something like that is m is equals to 6x plus 2. So our slope here is 6x plus 2. How do we get our main equation? This slope here, you know that the gradient is still the same thing as dy dx. So dy dx is equals to 6x plus 2. So in order to get our equation in y, we have to integrate this. So it will be integrate, and we put our integral sign here to the x. So when we integrate this, we have y is equals to, integration of this is 6x square all over 2 plus integration of this, we have 2x, then we have plus c. So the 2 here goes 1, 2 goes here, remain 3. That means our y is equals to 3x square plus 2x plus c. But there's a problem there. We have a constant here. Now how do we get the constant? We were given the values x is equals to 1 and y is equals to 3. That is the point where the slope passes through. So we can easily get the value of the constant through that. We have y, our y is equals to 3, right? 3 is equals to 3 open bracket, our x is equals to 1. 3 times 1 square plus 2 times 1 plus c. So that means our 3 is equals to 3 times 1 square is equals to 3 plus 2 times 1 is equals to 2 plus c. We make c the subject of the formula. We have 3 minus, this one come here because minus 3, this one comes here because minus 2 is equals to c. So we have the answer here is equals to minus 2. Minus 2 is equals to c. That means c is equals to minus 2 as the value for our c. So therefore the equation of the curve is equals to y is equals to 3x square plus 2x. C here is equals to minus 2, that is minus 2. So this here is the equation of the curve. So right here in the question 5a, it states that obtain the square y dx square for the following: y is equals to x cube sine x, and which is y is equals to x square in x. Now solving the first one, which is y is equals to x cube sine x. Now x cube and sin x are two different components. This one here is one component, the other one is one component. So solving this, we have to use the multiplication law, which is the law where you multiply each other, which is something like this: v du plus u dv is the formula. So we pick one as our u and we pick the other one as our v. So we pick this one here as u, we pick this one as v. So this one is v. Now our v is sin x times, what is our du? Du is differentiation of x square, x cube. Now when we differentiate x cube, it will be 3x square. That means our du dx is equals to 3x square, then plus our u, which is equals to x cube, and our dv. Integration of sin x is equals to, differentiation of sin x is equals to cos x. So we have x cube times, when we differentiate this, we get cos x. So this is the y dx. Now they told us to find for the square y dx square. That means we have to differentiate it 2 times. So the square y dx square is equals to, first of all, we have to differentiate this, then we differentiate this again. Now notice that the same thing is happening here, whereby we are having two different components that we need to use the same formula for. So we pick one as our u and we pick one as our v. You can pick this one as u and pick this one as v. You can pick this one as u and this one as v. So we have v times du dx. Our v here is 3x squared times, what is our du dx? Integration of sin x is equals to cos x. That is 3x squared cos x plus, now our u times dv dx. U is equals to sin x times, what is our dv? When we integrate 3x squared, it will give us 6x. That is times 6x. So we have plus, we now come to this other side again, we add it to it. We can pick this one as our u and this one as our v. So we have v times du dx. Our v here is cos x times du dx. When we differentiate this, we have 3x squared. We have 3x squared. When we differentiate this, then we add it again with u times dv dx. Our u here is equals to x cube, then our dv dx here, when we differentiate cos x, is equals to minus sin x. So that is equals to minus sin x. So now when we simplify this, we have our the square y dx square as 3x squared cos x plus 6x sin x plus 3x squared cos x. Then this one will become minus, since minus is influencing it, and minus x cube sin x. So this is our final answer for I. So now solving for figure 2, we write as y is equals to x squared in x. So right here we are finding, he told us to find for the square y dx square, which means that we need to differentiate it 2 times. So for us to differentiate this, since we are having 2 components, which is we are having x squared multiplied by in x, we are going to need to use this formula, which is v times du dx plus u times dv dx, which is the same formula that I wrote earlier for the first one. So when we differentiate this, we have dy dx is equals to what? We pick one as our u and pick the other one as our v. So I'm picking this as u and I'm picking this as v. So here we have our v times du dx. Our v is equals to in x. Our u is equals to this. Therefore, du dx is differentiation of this. So when we differentiate x square, we will get what? We will get 2x. So after that one, then plus u times dv dx. Our u here is equals to x square as usual. X square times what is our dv dx? Our v is equals to in x. Therefore, if we differentiate in x, it's going to give us 1 over x, which is a constant. Differentiation of in x is equals to 1 over x, which can also be written as x raised power minus 1. So we have x raised power minus 1. So when we simplify this, dy dx will be equals to 2x in x plus x squared times x minus 1. Using the law of indices, we are going to be having x raised power 2 minus 1 when we multiply both of them together. That is like the first law of indices. So we are going to be having x raised power 2 minus 1, which is the same thing as x raised power 1. I will be written as x. So our dy dx is equals to this. Then we differentiate it again to give us the square y dx square. The square y dx square means we are going to differentiate this one again. So when we differentiate this, notice that this place here has two components again. We have 2x and we have in x. And in this place, we have only one component, which is going to be easy for us to solve. So solving this, we pick one as our u and pick one as our v. So picking this as u and picking this as v. So that means the square y dx square is equals to v times du dx plus u times dv dx for this part here. Our v is equals to in x times, when we differentiate 2x, it's going to give us 2. So we have 2. So then plus our u times dv dx. Our u is equals to 2x times our v is equals to in x. And I mentioned earlier that when you differentiate in x, it's going to give us 1 over x, which can also be written as x raised power minus 1. That is x raised power minus 1. Then plus, when we differentiate our x here, we are going to get a straight 1. So when we simplify this, this is equals to 2 in x plus 2x times x raised power minus 1. Still using the same law of indices, we know that we have an invisible one here. So we have x times x raised power 1 times x raised power minus 1. When we multiply them together, it will become x raised power 1 minus 1, which is x raised power 0. So we'll be having 2 times x raised power 0 then plus 1. And we know that according to another law of indices, anything raised power 0 is equals to 1. So our final answer is equals to 2 in x plus 2 times anything raised power 0 is 1. So this 2 times 1 plus 1. And we know that 2 times 1 is still the same thing as 2. So no need of writing it again. Therefore, our final answer is equals to 2 in x plus 2 plus 1, 3. So this is our final answer. So the question 5b here says that find the mean value of 3x squared plus 4x plus 1 between x is equals to 1 and x equals to 2. First of all, what is the formula for mean value? The formula for mean value is equals to 1 over b minus a integral from b to a, then your function of x here dx. This is the formula for mean value. So this is what we are going to be inputting here. And note that 2 is equals to b and 1 is equals to a. So from here we can continue. We will have 1 over 2 here minus the 1 that is here, 1 integral from 2 to 1. Then what is our function here? We have it as in bracket 3x squared plus 4x plus 1. This is the x. So first of all, we can do this, then we integrate what is inside the bracket here. Here we will have 1 over 2 minus 1 is equals to 1. So from here we can integrate what is right here. We will have, when you integrate 3x squared, we will have 3x cubed divided by 3, and integrating 4x, we will have 4x squared divided by 2. Then integration of 1 2 is going to give us plus x, all close in brackets. Then you put our values from 2 to 1. So from here, this right here can be ignorable, can be ignored, because 1 over 1 is equals to 1, and 1 multiplied by anything will give the same value. So from here we are going to be simplifying it. We have 3 cancel 3 here. We have x cubed plus 4 here 1, 4 here 2, plus 2x squared plus x in brackets from 2 to 1 is what we are finding the value for. So right here, this means that find for the value of when this is 2, find for the value of when x is equals to 2 here, and when x is equals to 1 here, then you subtract the 1 of 2 from the 1 of 1. Now when x is equals to 2, when x is equals to 2, we will have this 2 here to be 2 cubed plus 2 times 2 squared plus here we will have 2. So from here we have 2 cubed is equals to 8 plus 2 times 2 square, we have 2 square as 4, then 4 times 2, 8 again, plus 2. So 8 plus 8 is 16, 16 plus 2 is equals to 18. So when x is equals to 2, this is giving us 18 as our answer. Then we find for the value when x is equals to 1. We have when x is equals to 1, we are going to have 1 cube plus 2 times 1 square plus here we have 1. So 1 cube is equals to 1 plus 2 times 1 square, that is 2 times 1, which is still 2, plus 1 here. Then when we add this together, we get 4. So this is when x is equals to 2, and this is when x is equals to 1. So when we subtract them from each other, we are going to be having 18 minus 4, which is equals to 14. Now this is the main value of this equation right here. So the question 6a here states that find the nature of the stationary point of the function x cubed minus 2x squared plus x plus 4. First of all, we need to understand what stationary points are. Stationary points are points of inflection on a curve. So imagine that we have a curve of something like this, then we have something like this and this. Here is a stationary point. Somewhere here too will also be a stationary point. So that is what stationary point is. So, and it has some certain rules. If we have y as a function of x, then to find for stationary points, at the stationary point, the y, the x is equals to 0. That is a stationary point. And to find for the stationary point, whether it is at minimum point or at maximum point, we use the square y, the x square. Now at the square y dx square, if the square y dx square is greater than 0, that means it is at maximum point, and if it is lesser than 0, it means that it is at minimum point. So that is what we were told to find for here, the nature of the stationary point. Now let's go on to solve this question. We have our y is equals to x cube minus 2x square plus x plus 4. So first of all, we are finding for our dy dx. dy dx is equals to, when we differentiate this, we have 3x minus 4 3x square minus 4x plus 1. 3x square minus 4x plus 1 as dy dx. And remember I said earlier that dy dx is equals to 0, so this is automatically equals to 0. From here we can find the value of x by using factorization method. While we are solving this using the factorization method, we are going to get this as 3x square then minus 3x minus x plus 1 equals to 0. So from here we can get we bring out 3x. From here we have x minus 1 from here, and from the other side we bring out minus 1, then we bring out x minus 1 equals to 0. Therefore we have 3x minus 1 and x minus 1 is equals to 0. So if we have it like this, we have x minus 1 equals to 0. That means x is equals to 1 at a particular point. And another place also we have x minus 3x minus 1 is equals to 0. Therefore x is equals to 1 over 3. So we have two values of x. That means we are supposedly going to have both a minimum point and a maximum point. But how do we know our minimum and maximum points? We have to use the d square y dx square. We check for the one that is greater than 0 and the one that is lesser than 0. So from here we have d square y dx square x square, means we are differentiating this one again, and when we differentiate it again we will get 6x minus 4. So from here we do, when x is equals to 1, what will be this? This will be equals to 6 times 1, which is 6 times 1 minus 4, which is equals to 6 minus 4, which is equals to 2. Now 2 is greater than 0, therefore it is a maximum point. But when x is equals to 1 over 3, let's go there. We have this dy dx is equals to 6 times 1 over 3 then minus 4. From here we have 6 over 3 minus 4. 6 divided by 3, 3 here 1, 3 here 2. So we automatically have 2 minus 4, which is equals to minus 2. Now from here we automatically know that this is the minimum point. We automatically know that minus 2 is the minimum point and 2 is the maximum point. So that is the nature of the stationary point of the functions of the function of this. So now the question 6b says that determine the integral square root of x minus 1 over square root of x dx. So how do we find this? First of all, I want to put this in some kind of fraction form. Here we will have square root of x is the same thing as x raised to power 1 over 2. So we have find for the integral of x raised to power 1 over 2 minus, now 1 over square root of x is still the same thing as x raised to power minus 1 over 2. X is power minus 1 over 2, then we have the x. So from here we can easily solve our question. Now integrating this, we have this is equals to x raised to power 1 over 2 plus 1 all over 1 over 2 plus 1 here minus x here raised to power minus 1 over 2 plus 1 all over minus 1 all over 2 plus 1. So from here it's easier for us to solve. X raised power, this we are going to get x raised power 3 all over 2 divided by 3 all over 2 minus, here we will have x raised power 1 all over 2 all over 1 all over 2. So from here, if we try and simplify it here, we are going to be getting 2 over 3 x raised power 3 over 2 minus 2x raised power 1 over 2. So if we put it back into its initial form, it will be something like 2 root x cube all over 3 minus 2 times root x as the final answer. So this here is the integral of this. So thanks for watching this video to the end. Please don't forget to subscribe, like and comment to my YouTube channel, and I will be posting more answers to past questions on this. Please turn on the notification bell. Thank you.